Hey guys, I am not good at videoing the lessons while I'm doing them, so I'm just going to make a short summary video of today's lesson if you didn't make it to class. Today we focused on the daily learning target. I can interpret and solve problems involving computer-generated histograms, and we talked about the fact that a histogram is a bar graph, and we are specifically interpreting histograms or bar graphs that approximate a bell curve or normal distribution, where it looks like our typical bell curves that we had done before. On a histogram, if something is represented by a really low bar, so like you have a really low bar or no bar at all, then that event is not very likely to happen. However, if it's represented by a bar that's not small and it's a significant size bar, then that is an action or an event that probably is somewhat likely to happen. It may not be extremely likely, but we know that it is somewhat likely that it will happen. Sometimes we want to get our data, but we don't want to estimate from a bar graph because sometimes that makes it a little challenging, and I'll show you that in the example we're going to do. Instead, we want to use data. And a lot of times I've noticed all the times on the old Regents exams and in the Barron's book that a lot of you have about the old Regents exams and also on this SAT and ACT exams. In addition to giving you a bar graph, they'll give you some actual data. So they're going to give you the mean and they're going to give you the standard deviation. And so when you get those two things, you're going to be able to calculate what is likely and what is not very likely. So how do we do that? Well, if I use that information, I don't even have to look at the actual histogram itself. If the, and I kind of sketched a little normal distribution curve, and this line represents the mean. And then on the one we had in class, before, we had like 0.5 standard deviations away, 1, 1.5, and 2. And so this represents 2 standard deviations away over here and -2 standard deviations away here. And you'll remember that very little data was outside of this. And in fact, if you go back to look at the normal distribution curve that you had when we learned about it, if you add up all these percentages on the outside, you get less than 5%. So a lot of times when I say in this lesson that we're going to be able to approximate something within 95% confidence interval, that means that 95% of the data falls within 2 standard deviations from the mean. And so we can be 95% confident that it will work. And then the other 5% falls outside the mean. All right, so it always makes more sense when you can see the actual work. So in class, I was telling the students that this has a lot of words, right? So there are a lot of words here. And so it's important that you are able to look at these kinds of problems and pick out the words that matter, the numbers that you care about. So we're talking about, I'm going to summarize this because you have a copy of this, but I'm going to summarize it. Basically, they have 30 students that they put into a focus group, and they asked these 30 students their opinion on this new backpack. It's a new style of a backpack. And they wanted to know if they liked it or if they didn't. Well, out of the 30 students in the focus group, only 9 said they liked it. So when you divide 9 by 30 on a calculator, you get about 30%. So out of the focus group, only about 30% of the students actually liked the new backpack. But the manufacturer wanted to know, well, is it possible that in the entire population, is it likely that maybe 40% would like the backpack? Because that's important, because you want to be able to sell. If only 30% like it and it's not possible that 40% would like it, then that might not be a good investment. So they have these computer programs that can actually generate data based on pretend imaginary students. And they just are checking probability is all. And so it runs these programs. Well, so they ran a computer program to choose 30 random students and ask and see what the opinions would come back as. And they did this 100 times, and they plotted the data here. So these each represent one of the sets of data, and each circle represents the 30 students that they questioned when they were doing their random data sets. And again, this is imaginary, it's on a computer, but it does approximate reality. If you just look at this and not any of the data below, you can see that they want to know, is there a possibility that 40% of them would like the backpack? Because if you look down here, it says, is it likely that 40% of the entire population would actually like the backpack, even though only 30% of the 30-person sample liked it? Well, if you look up at that chart and you go to 40%, not only does it have a reasonable size bar above it, but it actually has the longest bar. So this is the most likely scenario. And in fact, if you notice, they calculated the mean and standard deviation for us, and that is 40.4%. So it is actually, the mean is actually right at 40%. And the standard deviation is at about 8.9%, 0.089. So we can answer the question just by using the picture. But I took this one a little bit farther because the work times don't ask you something that simple. The work time problems want a range of data. So in other words, if the manufacturer said, I want to know with a 95% confidence level, what is my range of data? Well, I can look, and from the picture, it looks like a little under 2.5 to just about 60%, or a little over 25% to about 60% is where most of my data fits. So, but I'm just estimating, right? I'm just guessing. And as a math teacher, you know me, I like my definite answers. Well, so the way you calculate a definite answer is all you need from all that data they gave you was the mean and the standard deviation. So the actual formula is the mean plus or minus 2 times the standard deviation gives us about 95% certainty of where that data range is going to be. So we take the mean, which was 0.404, minus 2 times the standard deviation, which was 0.089, and we get 0.226 or 22.6%. So that's the low end. Then we do the plus part. So we go to the high end. So we go 0.404, that's the mean, plus 2 times the standard deviation, which is 0.089, and we get 0.582 or 58.2%. So what that means is that we can say with a 95% confidence interval that 22.6 to 58.2% of the population is very likely to like the backpack. Okay, so that's what we're saying. Like, it's not real likely that only 10% would like the backpack because that's too low. And it's not real likely that even 70% will like the backpack because that's too high based on our data. So we know that it should fall between these two numbers. And sure enough, 40% does fall between those two numbers. So we can use our data or we can use our picture. But for the range, I find this to be more specific than this picture, because how do I know that's 22.6? That's just, I have to estimate. I would have estimated that a little below 22. A little above 20%, but I wouldn't know where to put it. And then 58.2, I wouldn't be able to figure that out from here because 60 has significant data, but it's set far away. So I like this information for me better. So I'm just writing that basically that's the percentage. And yes, 30% that originally tested in the group fits, but so does the 40. So it is likely that 40% fits. Okay. And in the class today, I actually did go over number 1. So I'll go over number 1 for you on the work time. So here's our data. They plotted. There was an ecologist who wanted to know what percent of fish in a lake are codfish, right? So he knows he's got a lake and he knows there are about 10,000 fish in the lake. And he wants to know what percent of those fish are cod. So he catches 50 fish and he notes whether they're cod or not cod. And then he puts them back and he does that 500 times. So 500 different times he gets a sample size of 50 fish. And he realizes after he averages all of his samples that he ends up with an average or a mean of 24% or 0.24. And it has a standard deviation of 0.06 because all he would have had to do was average that out and put all of his findings into a calculator, and it would tell him the mean and the standard deviation. Here's a drawing of what he found, same data, you can see that the mean is right around here, which looks like it's just under 2.5. So that fits. And the standard deviation is going out. So most of the data should fit within 2 standard deviations, 95% of it. So we're going to calculate it. So we're going to take the mean, which is 24% or 0.24, plus or minus 2 times the standard deviation, which is 0.06. So we're first going to do the minus. The mean minus 2 times the standard deviation is 0.12 or 12%. And then the mean plus 2 times the standard deviation is 0.36 or 36%. So we can say with a 95% confidence interval that the percentage of fish in the lake that are cod will be somewhere between 12% and 36% of the fish in that lake. So the math behind this is not difficult. It's just multiplying, adding, subtracting. But what's more important is that you understand what they're asking. And they're just saying if data looks like a normal distribution or like a bell curve, if you get this look to your data, that if you just calculate the mean plus or minus 2 standard deviations, you will get 95% of your data will fit in that range. So that's what they're getting at. That's what the point of this. Just so you know, the lessons I was going to use, I looked a little bit deeper into them, and I found that they were a little confusing for distance learning and unnecessary. It was just going to be more confusing than helpful. So I went through a bunch of the regents. I know we don't have to take them anymore, but they're a great indicator of what to look for on any standardized test. So I looked at the regents and I looked at the Barron's Regents book that we gave most of you right before we went remote. So a lot of you have that Barron's book. All of this, and I put it on the top of this, and I also put it on the top of the note catcher. But all of this is in that Barron's book. So if you don't want to, print these out, then you can just go to the Barron's book, work out of that book, and take photos of that rather than writing it out and taking photos of your work. Because these are questions numbers 5 through 7 on pages 153 to 155. So you're welcome to just answer in the book and then send me pictures of that. If you would rather not print it out or type it up yourself, you can also just write 1A and you'll get that one right. There are only 2 more, so I want you to get on those and see if that seems easy for you. I will be posting the answer key at 9 in the morning. Tomorrow is going to just be more of this practice. So I will not be doing a new video lesson. It will just be this video lesson that is explaining how to do both days, because both days will be very similar, just more practice. All right. Have a great day. See you soon.